thank you everyone for taking the time to join us today. As Vanessa said, we're going to talk about data and how it's our new global currency and how it's driving business value for our businesses and also impacting our personal lives as well. So again, my name is Jeff Felice and I serve as the president of CertNexus. If you're not familiar with CertNexus, we're a global certification body focused on vendor neutral emerging tech. So we help validate skills and knowledge in areas such as AI, data science, data ethics, IoT, and cybersecurity. We work, albeit a small company, we work across the globe, and we've worked with a number of candidates from these organizations that you can see, as well as many others as well. So what will we discuss today? First, we're going to describe the major trends in data. Then we're going to define what data science is. And then we'll discuss the benefits and challenges of data science. Like any discipline, there's obviously going to be some benefits, but some opportunities for us, but how do we overcome some of the obstacles or challenges to realize that benefit? And then we're going to talk about a few business use cases for data science. As Vanessa shared, we will have Q&A at the end of the presentation allocated for Q&A, but please do submit your questions through the chat or Q&A throughout, and Vanessa will interrupt at any point in time if there's something that we need to answer real time as well. So we're going to start by learning a little bit more about you. I'm going to launch a poll, and this poll is, we want to understand how you engage with data today. So do other people provide or present data to you? Do you analyze data or present it to others? Are you responsible for collecting and manipulating or making data available? Or your job does not require you to interact with data? Again, there's no wrong answer here. It's really just to better understand who we have with us today. Great, and the answers are coming in. Let's wait a few more seconds here. Great. Well, it looks like we have a good distribution today of folks. So it looks like that we have a number of folks that are where data is essentially provided or presented to them. We have others that are analyzing data and presenting it to others, and some are responsible for collecting and manipulating the data as well. I'm really glad to see that no one has stated that your job does not require you to interact with data, because very few of those jobs exist anymore today, at least in a professional setting. So again, thank you everyone for participating in that quick poll. So let's get started. First, we're going to describe the major trends in data. So the first is that if you're not aware, what's now been coined as the data economy, or sometimes you'll hear the AI and data economy. And the data economy is this global digital ecosystem in which we gather data, organize it, and now we're exchanging it for the purpose of deriving value from that. So what does that mean? It means essentially that as organizations, data is becoming more valuable to us. As we'll see later, it's whether we're using it for insights in which to make decisions for our business. In some cases, we're monetizing data. We'll talk about that in a second. In other ways, we're actually trading data, right? Organizations are actually using it as a form of currency or selling it as well. And what we'll see is really the 2020s have become the decade of data. If you think back 10, 15 years ago, the most valuable companies in the world, they were typically energy companies or multinational manufacturers, right? So think about Exxon or companies like Procter & Gamble, et cetera, right? These were some of our world's wealthiest and most valuable organizations. And although they are still today, the fact is they've been superseded or supplanted by primarily big tech companies. And those big tech companies, even though we think about them maybe a little bit differently, right? We think about Facebook as a social media platform, or Google as a search engine, or maybe a cloud provider. Amazon, we think, as an online retailer, Microsoft as a software company, or Apple as a device company. The fact is that the underpinning of all their business models is data. Think about Facebook. Well, Facebook, how do they monetize? They monetize data, right? They use that data to help discern who should receive or view certain ads on their platform. Think about Google. How does Google
again, their primary revenue stream. How do they monetize? Well, when people search, that provides more information, so they can start using Google Ads, right? And you advertise through that platform. And again, even if you look at Apple, and everyone says, well, hey, Apple's really a hardware company, but think about all the data that drives that, whether it's the data that actually forms its AI, or the data it's now collecting, whether you're using your smartphone, an Apple Watch, or yet another Apple device. So again, all these companies now that are, again, the most valuable in the world are now built on data and leveraging data, again, to provide products and services, or they are the products and services themselves. And we're generating more data now that we're in this data economy than we ever were before. So essentially, in this year, it's estimated that we'll create 74 zettabytes of data in 2021. That's up from 41 zettabytes
from 2 years ago. Think about it, we're almost doubling the amount of data that we're producing, and it's expected with 5G that's going to grow exponentially more. And just to give you an idea of how large a zettabyte is, a zettabyte is 1 trillion gigabytes. So think about that. Think about the storage you typically have on your phone or your computer, right? And we talk about 1 gig or 2 gig. Now think about 1 trillion gigabytes, and then think about 74 trillion of those gigabytes, right? This is how large the volume of data that we're producing every year. And this is
creating a need to engineer data, right? So with all this data is not all tucked nicely and neatly into object-oriented databases, right? So think about all the data that's out there. We'll define unstructured data later, but a lot of this is unstructured. So it's in the form of text or images or video, audio, or other means like social media, where the data itself is not well structured or well categorized. Also, the challenge we have is with all this data, we would hope that it would drive better insights for our business and allow us to drive greater value. But it's not, because many times we don't understand our data. We don't, in some cases, we are not collecting the right data. And in other cases, we're collecting too much and we're just getting mired down in the data. So we have to improve upon that as well. And many leaders now are seeing themselves as the primary leader of their analytics agenda. As we talk more about business intelligence and data analytics, data science, et cetera, what the leadership teams have realized is that, hey, I need to take the reins to help define why are we using this data? Why are we collecting it? Why are we investing so much in these sources to do so? And data is becoming more predictive. We'll learn more about predictive analytics and prescriptive analytics in a few moments, but we're now seeing data being combined with artificial intelligence. There was Microsoft actually just released a new AI and natural language processing AI this past week that they announced, which now is the most powerful AI in the world, which has over 570 billion parameters. That's not data points, that's just parameters that it uses to help determine how to better process language. But what's happening also is we're generating a lot of data for use in AI, but we're also using AI to better model our data and to better leverage the data that's available to us as well. And there's also a need to secure data, right? You think about, the bad actors, the cyber criminals today, many times what they're looking to do is either lock us out of our data through ransomware or steal our data to use that and sell that potentially on the dark web or in other ways exploit that data. So we need to figure out, hey, not only how do we collect this data, and how do we organize it and utilize it for our business or other means or other uses, but also we have to figure out how to better protect it. And you can see some of the challenges that we have here. It's taken us longer to detect and contain a breach, and it's resulting in greater costs to us as well. And we also need to ensure that we're creating ethical solutions. For the first time in humanity, we actually are creating a technology that has the ability to actually complete some tasks that require human intelligence or some level of intelligence. And we're doing that with data sources that may not be as representative of the expected outcome as we would like. So machine learning doesn't understand ethics or bias. So they'll take the data and the data that's presented to them and they may actually predict an outcome that may be biased, or it may be deemed unethical. So we have to ensure that as we develop these solutions, that we not only secure them, but we also create responsible technology for good, that conform to our agreed upon ethics and standards. We also have to understand the complexity of data. So if there was a survey done by IDG, and they went out and surveyed some of the largest enterprise organizations globally, and what those organizations reported was that on average, most of them had over 400 different data sources to feed their business intelligence and analytics systems. And 1 out of every 5, 20% of them had as many as 1,000 or more data sources. So you think about it, you're like, gosh, that seems like far too many sources. But start to think about it. Even in a small business, you may have a customer relationship management system, a marketing automation management system, an e-commerce platform. You have various forms of social media. Maybe you have a financial system, right? And you can start to count up, even in the smallest organization, to get to a dozen or so data sources rather quickly. Well, now you can look at larger organizations where you have various supply chain management systems, enterprise resource planning systems, et cetera, and you can see how those data sources swell quite quickly. So again, what we have to understand is that, again, not only we essentially are generating more data, but there's more sources of data. And even as we extend that to think about the Internet of Things, right? Think about all the devices in our personal lives, right, that are generating data, right? My phone's generating data, my Garmin watch is generating data, I'm a cyclist, my cycling computer is generating data, I have a Ring doorbell which is generating data, I have a heating and cooling system that is connected to the internet. So think about all that data as well. So again, you can easily see even in our personal lives how we can have a half dozen or more systems generating data. And these data sources are impacting jobs. In fact, the World Economic Forum predicts that there'll be 97 million new jobs in the data and AI economy. So what we're going to see is some jobs will move towards obsolescence, as we have in every significant revolution. We'll see a whole number of new jobs that will actually be typically larger in number. And then for the majority of us, our jobs are just going to change, right? I think about when I first started working versus how I work today, right? The advent of the internet and how that's dramatically changed how I work, right? How mobile phones have, again, in the past 10 years, changed how I work again. It's going to be the same thing with AI and data jobs as well. But we also have to understand it's going to create opportunities. So Microsoft looked at a slightly wider view, and they said, hey, I'm not just going to look at AI and data jobs, but digital jobs, right? What are jobs that require digital skills? And they're looking at 150 million new jobs by 2025. And you can see some of the key areas, such as data privacy and data trust. We'd add data ethics to that, cybersecurity, then the analysis of data, and also the combination of machine learning and AI. Cloud, as we know, has been a growing technology over the past decade, and other data roles, and also software development as well. We're going to do another quick poll here, and we're going to define the data economy. So what is the data economy? Is it an online data commerce site? Is it cryptocurrency, a digital ecosystem in which data is exchanged to derive value, or a series of open source databases? Great, we'll just give you a few more moments here to answer. Great. And fantastic, and everyone looks like they've gotten this correct. I'm going to end the poll now. It's a digital ecosystem in which data is exchanged to derive value. Great job, everyone. All right, now we define some of the major trends and the impacts they're having. Let's just define what is data science itself. So data science is a discipline that involves accumulating data and then analyzing that data from which we want to extract value and then present the value of that data in a meaningful way. So what does that mean? It means, hey, we collect data from all those sources that we talked about before, right? Your e-commerce platform, your customer relationship management platform, supply chain management, ERP, social media, et cetera, right? So we're accumulating that data. Then we want to analyze that data. So what we're going to start to do is engineer that data. We're going to start to perform what we call ETL, extract and transform and load that data. And then when we start to extract value from that data, we're starting to do things like modeling the data. And from that, we start to present the value, right? We'll learn more about data analytics next, but we start to look at, hey, what's actually embedded within this data, the intelligence that we can extract from that, that'll be helpful to our business, whether to reduce costs, increase revenue, further our relationships with our customers, whatever the end goal is or the value you're trying to drive from the business, the data or the insights that'll support that. Broadly, data science is an umbrella term, so it includes many things such as data analytics, data mining. We actually, machine learning, although it's a separate discipline, is also closely aligned to data science. And big data, many times when we think about the storage of the data, big data becomes the source for data science itself. So if we look at data science, where it sits in our technical world, it really is a unique discipline, in fact, that it's a combination of three types of skills or knowledge. So they're mathematical skills, right? So we're going to use some statistics, probability, some linear algebra, potentially some calculus as well. We're going to have computing skills. Many of those will be based in understanding of potentially database technologies, also some programming skills, typically Python or a like technology. And then we're going to have some industry or domain knowledge, right? We need to bring some knowledge to this because as we model the data, we have to be informed about the data, although we may not know everything about the data, right? That's what our modeling, especially as we apply AI, is going to help us do. But we have to be have some basic understanding of the data itself. And so you can see as we start to put that together, data science sits in the middle, where some other disciplines are near adjacent to it, but slightly different, where we have traditional analysis, such as data analysts would perform, or software development, where you might have a Python or Java or C++ or C# programmer, or a machine learning or deep learning engineer, which again, although you may use some of those skills in data science, they are distinct disciplines. So let's just talk a little bit about more data itself. We're going to define a few terms over the next a couple slides. Again, this isn't a comprehensive data science class, but just to give you some basic terminology to walk away with as you begin or continue your learning journey around data. So the first is structured data, and I alluded to that earlier. Structured data is data that many of us are familiar with that actually resides in a database, right? So whether that's a Microsoft SQL or MySQL or Oracle or other database, it's data that essentially is in fields. It's well understood, it's well structured, and it's typically easier for us to access because we have thought about actually how we're going to store it. Unstructured data is not organized. And this data, it really, many times, again, as I alluded to earlier, could be text-based. It could also be graphics. It could be audio. It could be video. It could come from sources that don't essentially have a structured data format. Social media has presented to us many times in that way as well. So it's data that essentially is coming to us in a way that is not initially structured. Now, we may end up trying to structure it, but initially it's not. And also think, again, we talk about the Internet of Things. A lot of Internet of Things data is initially not structured as well. Is a great example of that as well. Semi-structured data sits somewhere in between. So we'll think about a CSV file. For those who aren't familiar, it's a near Excel format file, or XML or HTML, which are tagging or markup languages. This data many times is semi-structured, right? We can typically go into an XML document and it's structured, and we're able to translate that information in a structured way. The same thing with a CSV file is typically in rows and columns. And although it may not be as structured to the extent we want it to, we're able to more easily than not actually convert that into more structured data. Not that we always have to have all of our data in a structured manner to utilize it. You'll see with data science, it's not a requirement to do so, but it's helpful as we analyze data. Also, data analytics. So again, data analytics is a subset of data science. Some will say, hey, it's a separate discipline, and you will see a number of people that are performing data analytics that are not data scientists, but most data scientists will perform some level of data analytics. There's three typical types or main types of analytics that are performed. One is descriptive, and this is essentially where we take data and we describe what has occurred in the past, right? And we do this all the time, right? So if you take a quarterly sales report, right, that's looking at what happened the past quarter. Or if you take an inventory report, right, it's essentially inventory that's on hand now, or inventory you consumed over the past period of time. So we're all very probably familiar with a descriptive type of analytics. Predictive takes that one step further. What we do is we take historical data, and then what we do is we forecast what we think may happen in the future. So again, let's use sales, right? If I take sales over the past 3 years, that data, I'll be able to likely to predict or forecast what the sales are going to be for the coming year, right? So I can account for seasonality. I can start to look at, what our typical deal cycles are like, et cetera, all those things. And I'll be able to use that data, again, the historical data, to forecast what we expect to see in the future. Prescriptive goes one step further than predictive. What prescriptive data does, and many times, again, we'll use this in our data modeling, inclusive potentially of some machine learning or other AI, deep learning, et cetera, which is we take that data, and now what we're doing is we're actually determining there may be a few different options, and then we're prescribing what is going to be the best one to pursue. So think about that. Not only are we saying, hey, this is, these are the models, and maybe what we're now looking at is best and worst case and likely model, right? So there's 3 different models for our sales, and we're prescribing what's the most likely based on historical data, right? So it may be that in our predictive analytics, we weren't able to see certain trends that were occurring, right? Maybe there was a product that's cyclical in nature, right? That is only purchased every several years, right? And so our modeling that we initially did in the predictive wasn't able to capture that. But with the use of machine learning, they were able to actually discern from that data and learn and be able to dive deeper into that data and make a more predictive outcome and prescribe what is most likely to happen. So we're going to jump into another poll here. And we're going to define data science. So what is data science? How can it be defined? Is it collecting data, solving business problems using data, analyzing data to determine value, or all the above? Great. Appreciate everyone participating here. And everyone's getting this right. We'll just give us 5 more seconds here. Great job, everyone. So I'm going to end the poll, and everyone got this right. It is all the above. With data science, we are collecting data, right? And so we're typically working with a big data engineer who's responsible for administering that data. But the data science is the one that's responsible to collect that data. We're then analyzing that data, as we talked about. So we're extracting value from that, which is then going to help us solve business problems using that data. Great job, everyone. So now let's discuss some of the benefits and challenges of data science. So what are some of the benefits? One benefit that we're starting to see is the identification of new business opportunities, right? Businesses are starting to use data and better understanding trends and potential opportunities and essentially carving out entirely new businesses for their businesses or other entirely new businesses altogether, right? So we're starting to see this. Think about the number of new businesses that we have that have resulted from data, right? So I talked about Facebook. Facebook, or any social media site would not exist without data, right? So think about that. We have a whole industry, not only an industry, but some of our largest tech companies in the world wouldn't exist without data, right? We had software applications that existed that were helped us produce data, such as Microsoft Office, for years. But now we have businesses that are built on data. We also are, again, as we've been talking about, using one of the benefits is the ability to use data to make more effective business decisions, right? So again, using that predictive and prescriptive, we're not only looking back and saying, hey, this is what we've done, but we're now able to look at it and say, hey, this is what we've done in the past, and this is what we're likely to forecast, or even go one step further and say, these are essentially options, and what is prescribed for our business, right? So again, this can do all the things that we would want for a business, which are increasing sales, customer sat, help drive better results at the bottom line, et cetera, and the multitude of things that we want to do for our business. Some other benefits are product selection and delivery, right? We're now using data analytics to determine what products we develop, how we develop them, right? So think about that from a customer perspective, right? I'm drinking from a green water bottle, right? If I see that green water bottles are maybe around St. Patrick's Day in March, and maybe around the end of the year holidays, that is the biggest opportunity for them, I know that I'm going to essentially be able to identify those patterns and make sure I have inventory on hand so I don't sell out during those times. We're also going to be able to better identify our target audience, right? This is happening every day through social media, right? All of us, whether we participate in our business lives on LinkedIn or our personal lives on Twitter or Facebook or Instagram, et cetera, we're being targeted based on the information that we consume or we produce, right? So if I'm on Instagram and I like an image, or if I'm on Google and I search for, I'm a cycling enthusiast for a new bike, whatever it may be, that information is being captured and shared, and it's being used to better target ads to me, whether I wanted to or not. Right? It's also the customer experience, right? We can get closer to our customers through data, right? So those brands that I'm loyal to, I buy a lot of Patagonia, I won't say a lot, but I buy stuff from Patagonia for clothing, right? And so what they're starting to understand is me as a customer, right? What am I likely to purchase? What am I not likely to purchase? Why am I loyal to the brand? What are the things, how I interact with the brand? Whether I interact, it's responding to, reading newsletters, responding to potential promotions, how I engage on social media. All of that is, again, they're gaining a better understanding of me, Jeff Felice, as their customer, and hopefully building a further relationship with me. And then it's risk mitigation as well, right? And this is whether it's operational risk, right? We see this in many physical industries. So think about critical infrastructure, energy, manufacturing, et cetera, how we better mitigate downtime of our equipment or potential safety risks, et cetera. And also strategic risks, right? How do we better stay abreast of industry trends, and how do we essentially not only stay abreast of them, but potentially setting those trends ourselves? And so using data to do that as well. And then there's a number of other things in risk mitigation, especially get into more compliance heavy industries, such as finance or healthcare, et cetera. What are some of the challenges? And we're glad you're all here with us today, but because one of the largest challenges is scarcity of qualified talent. I serve on several committees in the industry, and the largest barrier right now to organizations realizing the full potential of their data is access to talent. And so, and in fact, some of the largest tech companies are paying exorbitant rates for talent, and again, having difficulty retaining that talent because there's so much demand. In fact, for every 4 data science jobs available today, there's roughly 2 people that can fill those. So think about that. I was on a webinar yesterday, and literally people were saying that they are at a standstill with some of their projects because of the lack of talent. And that talent's not only with data scientists and data analysts, but also business professionals that understand how to better utilize data. So whether that's your project or product manager, or someone in marketing or sales, right? Think about all the data you have in your CRM or marketing automation platform, or across the business, supply chain management, operations, your ERP systems, your financial data, et cetera, right? So the ability to leverage that data. We also have some results-based issues. Right, is lack of clearly defined goals. One of the biggest challenges we have is we think data is going to solve all of our problems. Well, we need to understand what the problem is or what the opportunity is before we start to rely on our data to help us solve for those. So many times, because we haven't defined those goals, we potentially collect the wrong data. We may have some dirty data, some data that is essentially going to skew our results. And then our ability to essentially, when we model that data, move it into a production system so we can better leverage future data as well. We also have data quality. So again, this is accuracy, completeness, the relevance of the data, the timeliness, right? If we need data that is, no more than 90 days old, and we're looking at data from 3 years ago, is that really helpful? Data privacy, there's more and more data privacy laws that are being enacted. So many of us are probably familiar with the GDPR out of the EU, but there's also now state laws that have been enacted in a handful of states in the US, and we expect that to continue to grow. Potentially there's a federal law. And there's other laws, again, across the rest of the world that, again, may impact us for us that are, involved in global companies or have global citizens participating in our business. And then the lack of standardization. So data itself is unfortunately not standardized, right? All these platforms and places where we can get data don't always have data structured in the same way. How we report data is many times inconsistent, even within a single organization. And how we communicate data, right? So there's a lot of ways that we can increase this standardization that essentially will increase our understanding of the data that's available to us. So we're going to do our next poll here, which is also our last one. So what are some expected benefits of data? So, and this is what you expect, right? So is again, and if there's not any, again, if you don't engage directly within data in your job, you can just select what you think would be most interesting. But how do you think you'll use data? Is it to identify new business opportunities, make more informed or better decisions, improve your customer experience, or mitigate risk? Great. And we're seeing all the answers come in here. And we're seeing it right across the board, almost split evenly. The most are making better decisions, improving customer experience, and mitigating risk. Great job, everyone. Thanks for participating. Okay, we're into our last section here, which is business cases. And we're just going to draw on three, one for finance and economics, healthcare, and then cybersecurity as well, IT and cybersecurity. So finance and economics, if you're in the financial industry, you're probably familiar with this already, or as a consumer of a payment card, you probably know that many organizations now are monitoring our payment cards, right? For potential fraudulent activities, a great example of that. Also to better understand how are we using that card and maybe how they promote, right? I've been an American Express customer for a long time, and American Express has a lot of data on me and the purchases I've made, and are able to start to tailor certain promotions to me based on that purchase history. We're also using it to help improve our lending capabilities. There is some concern here, and we have to understand some biases that may be inherent in our data. For example, there's a pretty famous example of someone was denied a loan even though they had great credit history because they lived in a certain zip code, and people had higher failure rates in that zip code. So the person was initially denied a loan and then offered a loan at a much higher rate, right, despite their good credit history. So we have to continue to work on those data modeling and algorithms to improve upon that. And also to forecast economic conditions, right? Our economic advisors or investment advisors now are using AI and data modeling to help us better understand what the future holds for us. It's not a crystal ball, it's not 100%, but it is getting enabling us to have potentially better results from our investments. The healthcare industry, medical imaging is a place where data and AI is now being used extensively as a first set of eyes on imaging. We still want a health professional to review that information, but sometimes it is with the use of data modeling and AI, we're able to pick out potential disease states that are not always visible to the human eye. In pharmaceutical development, again, using it heavily, as well as the analysis of those studies, and even risk scoring for chronic diseases. Really interesting, a few weeks ago, IBM published a study completed with the Michael J. Fox Foundation, where if those who are familiar with Parkinson's disease, it progresses in a nonlinear format or way, and now they're actually able to help better predict for individuals how they may progress through those various disease states, which is really exciting for that community to help better treat and support individuals suffering from that disease. And then cybersecurity, talking about intrusion, detection, and prediction, right? So how do we stop, for example, phishing emails, right? So how do we essentially able to determine what may be a phishing email? How do we make sure that doesn't get into our environment? How do we predict likely behaviors that happen that may, again, result in an incident? Data protection, the same, right? We're using many more capabilities now to help protect our data. And again, all of the various cybersecurity solutions now, from whether it's a firewall or it's an endpoint solution, it's phishing detection, and even in our incident response as well, et cetera. There's a variety of these technologies now that are using AI, and many times the reason why is because our cyber criminals are now using AI as well, right? So we have to use technology to combat technology that is, again, operated or supported by people. So as we start to wrap up here, a few things that I want to take away. One is the skills map. I like to share this, which are, what are the different skills I need as potentially as a data analyst, a machine learning engineer, which we've talked a little bit about, a data engineer, which is, again, our big data engineer, the people that are essentially administrating our data, and a data scientist. And you can see the data scientists, and you can see at the bottom the key being, something that's not that important to someone important to very important. And you can see the difference here between a data analyst and a data scientist. Now, a data analyst is really going to be focused on the visualization and communication. They may have some programming tools or tools that are available to them, like Microsoft Power BI or Tableau that they're utilizing. Again, they're going to have some understanding of statistics, et cetera. But they're not going to be, it's not as important that they understand what wrangling data is, right? How do I take my data and make sense of it? How do I use machine learning to further my data models? They don't require software engineering skills like Python or the ability to utilize Jupyter. And they typically are less engaged with higher level math, such as multivariable calculus and linear algebra. Where the data scientists are going to have more of these skills. Now, we always say to data scientists, you're never going to walk in the door with all these skills as data scientists. You're going to build these skills over time like you do in any job, right? So you may come from a programming background. You may come from a mathematical background. You may come from a data background, right? A database background. The fact is, you're going to be able to build on top of those skills as you move into a career as a data scientist. And again, to further that, again, you may learn some machine learning as well. What does a pathway look like? If you look at our partner here, New Horizons, they have a pathway at the bottom listed here. And I should have started off, and I think Vanessa is thanking New Horizons, our authorized CertNexus authorized training partner for upstate New York, for hosting this event. I apologize for not doing that earlier. But they've actually have worked to create paths for individuals that are interested in certain jobs. So if you're, a business person, a product or project manager, someone in a leader, or again, in a various department in marketing, sales, et cetera, and you're going to typically be a consumer of data. You may do some analysis of data. You at least want to have those introductory courses. You want to have a business understanding, furthering what we learned today, right? What is structured versus unstructured data? You'll start to learn where data sources are, what are typical data repositories, what the data lifecycle looks like, and other essentially foundational terminology, the application of those technologies from a conceptual perspective, and then the business use of those technologies as well. Whereas if you're a data analyst or data scientist, you're going to need some more hard skills, right? Going beyond the knowledge, right? So whether that's using everyday tools today that we use for some analysis, like Excel, or moving into some of the more popular business intelligence tools like Tableau or Power BI. And then data scientists, you can see, again, we're going to further those skills again with typically Python Python and R are the two primary languages used in data science. And then also looking at how do you further those skills and start to be able to now do things like extract and transform and load data, how to essentially wrangle data, how to model data, et cetera. And there's CertNexus. We have a certified data science practitioner that we partnered with New Horizons to deliver. And then also furthering that, including the certified AI practitioner for those who want to take their data modeling one step further. And then there's a host of electives based on where you may focus, whether that's querying information, a heavier use of Python for visualization, or again, thinking about data ethics, right? So again, we talked about that earlier, and the ability to ensure that our data is not biased and is producing the appropriate results. So in summary, we now understand data is transforming business, right? We're now in this AI and data or data economy, where now our world's most valuable companies are all data driven. We're realizing that as data grows, right? Talked about those 400 data sources for large companies on average, as many as 1,000 or more, but even small companies, dozens or more. And that now we have to have individuals that are able to engineer that data for use. It's important that we understand that, listen, data is beneficial. It can help us move forward our business, but we also have to understand that there may be some challenges with it, whether that's resourcing our people that know how to manage data and make use of it, whether it's how do we store our data, how do we extract that data, et cetera. That we also are now using data throughout industry to automate processes, improve our decision-making, and potentially create new businesses. And there are multiple paths for data roles. So if you are a data professional today or looking to become one, there's a number of different job roles, and each one of those have different requirements for individuals. With that, I'm going to hand it off to our partner, Joe Mignano, who heads up New Horizons, and he's going to say a few words, and then we're going to open it up for Q&A.
Thank you so much, Jeff. Thanks for doing that presentation. I'm not sure what I could say that would augment what you said about data science, but it's interesting. I'll just say just briefly from a perspective here from New Horizons, from managing the Buffalo, Rochester, Syracuse, and Albany locations. New Horizons, we're blessed and we're cursed. We offer a lot of courses. We help in a lot of different technology areas. We help with learning and professional development. Of everything we help with, data science has been the biggest area for us of interest. I'd say since COVID started, roughly about 2 years ago. Two big things going on, throughout Western and upstate and central New York right now are employers are simply trying to do more with less. Employees are asked to be more efficient with the software at their fingertips. And in general, even before COVID, I think a lot of companies in our area really started to go through a digital transformation. Everything is digital. And I think those two trends have really driven a good amount of interest in our broader, data science portfolio. As you were talking about the difference between data science and data analyst, I think we have tons of courses for different data analysts. On the end user level, we teach courses on things like Excel, right? All the way through to Power BI and Tableau. But as you get closer to the other end of the spectrum, the data scientists, right? We have courses on SQL, we have courses on Python, we have our data science practitioner course, which leads to the CertNexus, data science practitioner certification. There's just simply are a number of ways we can help the average, organization, the typical organization in our space when it comes to data analysis and data science together. So I think your presentation really hit on a few of the hot button trends that are going on kind of broader over the world. As you mentioned, CertNexus is a global company, but we see that interest here locally. So it's been fun working with clients who previously only worked with us for things like Microsoft Office and kind of business skills training, seeing them get more advanced with the type of work that they're doing internally. So I guess that's the only insight that I could possibly add to your remarks there, Jeff. Vanessa, do you want me to do the drawing for the $25 gift card, or do you want to do questions first? What works well for you?
Sure, let's go ahead into the drawing, and then we do have a couple questions in the chat that we can tackle right after.
Okay, so bear with me. I promise everybody this is very legitimate. I'm going to Google. I have my random number generator here, and I'm looking at the attendee list, and I'm going to make sure everyone has an equal shot. Looks like my number is 7. So 1, 2, 3, 4, 5, 6, 7. It looks like our winner, if I go back up to the top of the list, is Adria Ripka. Adria, I'm not sure if you're online or not, but Adria, you're the winner of our $25 Amazon gift card. So if you're there, congratulations. And if you're watching the recording, still congratulations. We will get with you after the webinar to get you your gift card. Make sure Amazon is not blocked in your spam filters or blocked in Outlook for you, so you can get that gift card from us. Good. That's our gift card winner, Vanessa, Adria Ripka.
Great. Fantastic. Thank you, Joe, and a special thank you to Jeff for the awesome presentation. So we've got a couple questions that came in through the chat. And I do see Adria commented. They're here. Great. So more information to come on that. So first question is, what's your most popular data science course that you offer?
Oh man, on our side, our most popular data science courses, well, certainly on the data analyst side, certainly our Power BI courses and our Tableau courses are very popular. On the data science side, though, it is the data science practitioner course. So we have a number of folks in technology that are charged with wrangling data or starting to move into machine learning, anywhere in that kind of general technical skill area that are lacking a certification, right? That are lacking the ability to show to their employer that they're qualified to do this work, or that they have the skills needed to actually execute on projects that the company is trying to move forward with. So we found a really good cycle of folks within the Western, Central, and Upstate New York area that are looking for some sort of capstone of the training and education programs they already go through with New Horizons. And like I said, that data science practitioner course is actually fairly popular right now, on the data science side. So whoever asked that question, would love to share the outline with you. And if not, you can just pop right over to our website. You can search for CertNexus or just do a search for data science. You can see what's included. It's a 5-day course. Just like all the other courses from New Horizons, you get the class recording and the free retake, for 6 months. So it's a pretty nice benefits for those that are looking to take that course. And yeah, I'd say that's the most popular one, Vanessa.
Great, thank you, Joe. Another question that popped in the chat. What's the difference between a data analyst and a data scientist?
Oh, that sounds like a Jeff question if I've ever heard of one.
Yeah.
Jeff, why don't you take that?
Yeah, and I think we started to touch on that as well. But typically a data analyst is they may be doing some massaging of the data, but they're typically using a business intelligence tool. Again, whether that's a Microsoft Excel or Power BI or Tableau or a similar tool set, and they're taking that data and typically creating presentations, including graphs and pie charts, et cetera, whatever it may be, right? But they're taking that data and then they're also most often responsible for presenting that data as well, whether to another team member, leadership, whatever it may be. A data scientist is going to be more responsible for being the in-between, where your big data engineer or your IT administrator is essentially responsible for administering the data. That data scientist is going to be the person that says, hey, we have all this data. Now, how do we make sense of it so I can hand it off to the data analyst? Now, in small companies, you may have someone that performs both duties. They may be the analyst and the scientist, right? The data scientist may be building middleware solutions, et cetera, to have, business intelligence available, to the business. But in a large, mid to large size organization, your data analysts, and I should say data analysts can live anywhere in the organization. It could be in sales, marketing, finance. You may have a data office with a chief data officer, so they can sit in any of those. And the data scientists, again, will typically be more technical oriented.
Very good. Thank you, Jeff. And the last question, I'm a project manager. Is there training for me?
Yes, one of the things that we're seeing at our what we call our think level, which is our data science for business professionals, or DS Biz, we also AI Biz, and through our partnership with New Horizons, we run these classes almost on a monthly basis. And about 40% of the people that are attending these classes are product or project managers. They're now have been assigned a project that they're going to lead that is data intensive, and they want to be able to engage with the technical team members. And so they need to understand some of that foundational terminology. Or product managers, right, that are leading new products or product development or new features that are more data intensive. So so we would recommend they would start with that knowledge-based course again, which is the data science for business professionals. And then look, determining beyond that is really what, whether you have to perform any analytics or more, extensive work, then you can look at some of the data analytics or science courses that Joe referred to earlier. But definitely starting with, grounding yourself in that business level, foundational level of understanding of the terminology, the concepts, and how it's applied for business use.
I would just add on to that. We actually have had our IoT practitioner course, which leads to the CertNexus IoT practitioner certification. We have had project managers and program managers move through that course. And if you look through the outline, there actually are specific sections of that course geared toward, like managing an IoT project, closing off an IoT project. So I have seen locally project managers in the IoT course specifically, and certainly the think level courses that Jeff mentioned as well, DS Biz, AI Biz, IoT Biz, et cetera. So it definitely is an interest, emerging technology in general for project managers, at least here in New York.
Yeah, Joe, and to that point too, I think what many of us are starting to think of IoT as not as almost as a separate discipline, although it is, because it's used so extensively, especially in what I consider physical industries. That is not only, just as I alluded to earlier, critical infrastructure in energy and manufacturing, but think also about transportation, right? Think about the supply chain challenge we're having around the world today. But we're improving upon that with the use of IoT, but it's also used in agriculture, healthcare, and a variety of other industries as well. Wonderful.
Thank you both for that information. It looks like we are caught up with all of the questions that came in. So I would like to remind everyone that we were recording today's event, so we'll share a link to that recording for anyone who wants to review later or share with colleagues. So a big thank you to Jeff and to Joe for the wonderful presentation.
Thank you. Thank you everyone for the time today.
Yeah, thanks everyone for joining. Good to see some familiar names on here. AJ, we'll get to you with your gift card soon. All right, or I'll let Grant do it. All right. Bye, everybody.